So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we also do see and appreciate the beauty in the simpler problems. So today, our problem comes from the MIT 2022 Integration B Semifinal number 1, and problem number 4 is our main focus today. We'd like to group this problem into the polynomial fractions category. So our problem today is the integral from x equals to 2 to x equals to 5 over 2 of into bracket x cubed minus 3x close bracket cube minus 3 open bracket x cubed minus 3x close bracket, all that over the square root of x squared minus 4. So this problem looks very intimidating, just in terms of just how things are all scattered about and around. But we'll attempt to solve it in a way that is easy to appreciate. Okay, now going forward, before we jump into the solution, first, a big vote of thanks to our subscribers. We are growing at a great pace, and we would like to thank our subscribers for continuing to give us that support. For our first-time visitors, all we can say is that here at Everyday Mathematics, what we do is we do get these very interesting problems, and then we come up with some solutions and share with you guys. For repeating visitors who haven't subscribed, we beseech you to subscribe to our channel. We would really appreciate your support. Now, jumping into the solution of this problem, as I always say, I don't really like the square root sign. So with these integration problems, what I try to do is I always try to substitute those away. So the first thing I would do is I say let u be equal to the square root of x squared minus 4. And that means that u squared is equal to x squared minus 4, meaning that, in fact, we made a small error here. So meaning that 2u du dx equals to 2x. And therefore, since from here we see that x squared is equal to u squared plus 4, and therefore x is equal to square root of u squared plus 4. And it means that now if you divide both sides by x, and also if the 2's cancel, so we have u over x, which now becomes square root of u squared plus 4 du being equal to dx. So we can substitute for dx with u over square root of u squared plus 4 du. Now also when you look at the limits, when x equals to 2 here, that means that u is equal to x squared, which is 2 squared, which is equal to 4 minus 4. So the entire thing becomes 0. U becomes 0. When x equals to 5 over 2, what that means is that x squared is equal to 25 over 4. 25 over 4 minus 4 is 9 over 4, which the square root of that is 3 over 2. So u becomes 3 over 2. Now, therefore, our integration, as shown here, becomes, we can try and simplify fast before we bring in the substitution with u by pulling out the x's. So we have x pulled out becomes x cubed times into bracket x squared minus 3 all the power 3 minus pulling 3x out, pulling x out becomes 3x times x squared minus 3 over the square root of x squared minus 4. And therefore, the problem now becomes tractable. So we can substitute for x squared minus 3. And since x is the same as square root of u squared plus 4, we can plug that in. And since we have a 3 here, so we have u squared plus 4 to the power 3 over 2. And then u squared minus 3, x squared minus 3 is the same as x squared minus 4 plus 1, so which is u squared plus 1. And the same thing applies on this side. And the denominator here is u, and the x is the same as u over square root of u squared plus 4 du. So this square root of u squared plus 4 would cancel with the 1 square root of u squared plus 4 here, and this square root of u squared plus 4. And so our problem becomes much simpler, and also this u and u would cancel out. So we have now here u squared plus 4 times u squared plus 1 to the power 3 minus 3 times u squared plus 1. And so multiplying that through, we can pull u squared plus 1 out, and so we are left with u squared plus 4 here times u squared plus 1 squared minus 3. And so going further, that means that our problem becomes the integration of u to the power 8 plus 7 u to the power 6 plus 15 u to the power 4 plus 10 u squared plus 1. And obviously the limit is 0 to 3 over 2. And so obviously u to the power 8 becomes 1 over 9 u to the power 9 plus 7 u 7 u to the power 6 becomes u to the power 7. 15 u to the power 4 becomes 15 over 5, which is 3 u to the power 5, plus 10 u squared becomes 10 over 3 u to the power 3 plus u. And so we have the limits as shown here. So substituting in the limits as shown here can quickly boil down to, it just requires simple arithmetic. I decided to just go the hard way of breaking it down. Eventually, the numbers get simpler, and at a point, we get 1 over 9 we get 1 over 9 3 to the power 3, 7,533 plus 2,176 over to the power 9. To the power 9 is 512. And so the numerator here becomes 262,143, which is the same as 262,144 minus 1. This here is the same as 512 squared, or 200 to the power 9 squared. So essentially what this reduces to is 1 over 9. Since this is to the power 9 squared, we are left with 2 to the power 9. And then 1 over 2 to the power 9 becomes 2 to the power negative 9. And this here is the answer of our problem. It seemed a little bit intimidating, but at the end of it all, it's actually a very interesting answer that we get. So before I say my parting shot, just encouraging our visiting non-subscribers to subscribe to our channel. We'll really use your support. It is for the fact that the subscribers continue to show us the support that we get the motivation to show up time in and time out, to just share the love that we have for mathematics with you guys. It was a wonderful opportunity hanging out with you and sharing the solution with you. I went a little bit faster, but if you have any question, please leave a comment in the comments section. If you need notification every time we do upload a video, just press on that notification bell. But other than that, thank you so much. Until next time, Allah Hashem.